Hello, everybody. Nice to see you all. So before I start out talking about airspace management, I thought we would just talk a little bit about why we're all here. I'll speak for myself, but I imagine many of you are here for the same reason, which is that we think there's a huge opportunity to bring the benefits of flight to people in their daily lives. And just a quick little personal story. I grew up in Santa Monica. You met my best friend Cyrus yesterday when he presented. And we grew up at the Santa Monica airport. And when we were 13, we had an opportunity to start volunteering for a nonprofit there at the airport called Angel Flight West. Angel Flight West is an organization of about 1,500 volunteer pilots that fly people in medical and financial need in the western US. And so 2 days a week after school, we would go to the office there and call volunteer pilots and say, hey, are you available to fly this mission? This person needs to get to UCLA or get to Stanford or whatever. And once in a while, we got to ride along on these flights as a co-pilot. And it was through this experience that I really started to appreciate that so few people in the world are actually benefiting from what aviation has to offer. And in fact, I didn't know this until recently, fewer than 20% of the world's population have ever actually stepped foot on an aircraft. So it's this passion for bringing the benefits of flight to people in their daily lives that's really driven me, everything I've done personally and professionally. And in 2014, I started really gaining an appreciation for the capabilities of small drones. Having grown up flying airplanes of all kinds and helicopters and stuff, I've always been passionate about this, but I never really saw the opportunity to actually fulfill this personal mission of bringing flight to everyday life. Now with drones benefiting from technologies from the internet and from cell phones, et cetera, you could go and buy an awesome little drone for $1,000 that could stream video, anywhere you want to fly in the whole world. It's pretty amazing. Anyway, so our mission at AirMap is to make flight part of daily life, and we do that by contributing the airspace management system of the future. There are very important solutions that we deliver today that are supporting drones. So this is just a bit of our view on how the industry is evolving. I'll go through this quickly because I'm sure you guys have spoken about this a lot over the last couple of days. But when I was growing up, built these little balsa wood models, and you go to the AMA flying field and put gas in the engine and fly it around and crash it usually. Then now you can go to Best Buy and buy one of these drones for $1,000, and it's amazing. It's easy to fly. Capture incredible video and photos of your friends, and millions of these devices have been sold. Now enterprises are figuring out how to use these types of drones in their business, right? In industrial inspection, public safety, mining, construction, insurance, et cetera. The next phase is really going to be more B2C. So things like package delivery services will start to benefit people in their daily lives. And eventually you'll be able to fly to work on giant drones, eVTOLs, what we've all been talking about last couple of days. Along the way, drones will go from being something that you own and you pilot to being available as a service. So just like AWS or Azure or Google Cloud, et cetera, have allowed businesses to access servers without having to own them and manage them, same will be true for drones. So if you need to get some imagery of your roof, or you've lost your keys at home and you need them at your office, you can just go on the internet and say, bring me my keys, and a couple minutes later your keys show up. You didn't really know how that happened, but the drone did that for you. All of that requires a totally new way of managing the airspace. So let's talk about what's different. Why do we need a new system for managing the airspace? I'm going to sort of provide 4 provocations here. First one is that today airports are near cities. Tomorrow cities are airports. So that fundamentally changes the policy landscape. It fundamentally changes how aircraft interact with people. Today, the city of San Francisco has an airport way south of the city. Tomorrow, San Francisco will be the airport. And this is not just happening in the future, it's actually happening now. This is a Matternet drone on top of its docking station. Matternet drones are routinely flying in cities across Switzerland right now, every single day. The future looks more like this, thanks to Uber for this vision. But aviation is going to be integrated into city life. It's going to totally change the urban landscape. Okay, second provocation. We're talking about massive scale. Scale like aviation has never seen before. Today, AirMap is providing airspace services for more than 100,000 flights per day. To give you a sense of what that translates to, the FAA provides air traffic control services for 40,000 flights per day, so we're doing 2.5 times as many. The FAA has 15,000 air traffic controllers. My company has a total of 70 employees. So how do you achieve that kind of scale? We have to borrow methodologies from other highly scaled systems like the internet. One way that you do that is through open interfaces. An example of an open interface is a platform software development kit that we recently open sourced, made it a part of Drone Code, which is sort of the Android operating system for drones. And so now any developer that's building a drone or building an application for a drone can easily plug into the airspace management system. Another way is to make this whole developer ecosystem really friendly. You have to make it easy for developers to use these services. And you have to make these services applicable across the whole value chain of the aircraft, from the chipset all the way to the operator. Third way that you do this is by creating protocols that allow airspace service providers to interconnect. One example of this is a recent project we did with Alphabet's Project Wing, which we demonstrated in Virginia, where their airspace management system was managing some flights, our airspace management system was managing some flights, and we interoperated through a common protocol. And lastly, you need to be able to integrate these systems with the traditional air traffic management system. This is an example of an integration that we did with the Spanish air navigation service provider called ENAIRA. These are the people that manage air traffic in Spain. And through this demonstration, the air traffic controllers on their radar scopes could see where relevant drone flights were happening. So not all the drone flights, but if they popped up above a certain altitude or they're close enough to an airport, it was alerted to the air traffic controller on their radar screen. And here's a view of what a sort of consolidated airspace picture looks like. This is Switzerland, where we're deploying Switzerland's unmanned aircraft traffic management system, consolidated view of all of the manned flights and drone flights at the same time. Okay, third provocation is that the role of air traffic control is really changing. It's historically been about safety. Now the airspace management system can provide a lot more value to the operations in the form of enabling efficient navigation. This person in the air traffic control tower has a really, really important job. They have to make sure that two aircraft don't collide. But it's actually a pretty simple job. Managing the airspace in the low altitudes is extremely complex. We're talking about aircraft taking off and landing on city streets, flying around where you live and work, a high school, all sorts of complexities with the weather, right? Winds swirling around buildings. And then a whole new level of scale, as we talked about before. So deconflicting flights from one another is happening at a whole new scale, and the separation standards have to come down significantly. And of course, we still need to maintain the same level of safety, but we need to be able to bring a lot more aircraft into the airspace. So you have to automate that. That can't be done with a human. This is a picture of a optimized route for a drone flying around San Francisco. So you can see that the most efficient and safe path is not going to be a straight line. But anyway, so fourth provocation is that the role of the airspace manager and the pilot are merging. So if we think about this picture, you have the pilot and her helicopter, and they each have a role in this system. The pilot is responsible for flying the aircraft. She has to make sure she doesn't collide with other aircraft. She has to make sure that she doesn't collide with obstacles. She has to handle emergency situations. The aircraft is there to be a reliable platform that usually operates safely. Well, in the future of automated flight, these roles change, right? The pilot is no longer going to be in the cockpit. So who's responsible for making sure that it doesn't run into obstacles? Is the aircraft capable of doing that on its own? Well, that's never before really been done. Aircraft haven't been responsible for avoiding obstacles. So the certification of the entire safety system has to be holistic. You have to consider the contributions the aircraft makes, the contributions the pilot makes, and the contributions that the airspace services provide. This is a command and control center of the future. This is EHang from China. This is their command and control center for their EHang eVTOL. And you can see these people are there flying the aircraft from the ground, right? So kind of looks like an air traffic control center. This is the future. Operators on the ground are going to manage dozens, hundreds, thousands of flights simultaneously with a single person, eventually no person at all. The airspace services that are provided are going to be taking over a whole lot of the responsibilities that the aircraft and the pilot once had. So that concludes my talk. I'm happy to take any questions.
That was great. Do we have any questions in the room? Okay, so you've got two nice ones from the audience. Do you want to start with cybersecurity?
Sure. Yeah, we could be here for days and talk about cybersecurity. You know, clearly, extremely important topic, very multifaceted. I can, only speak for my own experience. We started with cybersecurity as sort of the first tenet of the system. We had to make sure that we employed every, potential cybersecurity measure, right, to protect the system. If people are going to trust the system, it has to be secure. We have to constantly keep this thing updated, make sure that, we're responding to any new vulnerabilities, et cetera. So, it is absolutely a fundamental tenet in the overall integrity of the system. Hard to go into a whole lot of details, but yes, it's important.
Okay. So what's the difference between your 100,000 daily flights and the FAA's 40,000?
Yeah, so certainly we're providing a different kind of service than what the FAA provides today. We are not yet deconflicting flights from one another, which is the only thing that the FAA really does. We're not doing that yet because flights are not yet permitted to fly beyond visual line of sight, with rare exception, and we are supporting those in rare exception. But what do visual line of sight drones need right now? They need geofencing so that they don't fly into unsafe airspace. Those are both fixed and temporal restrictions. So if the president comes to town, if there's a wildfire, if there's an emergency like an ambulance that's been called out, those kinds of things, we can provide temporary geofences for those. We can provide authentication of the operators, ultimately what's being called remote identification. Also authorizations for drone flights in controlled airspace. So October last year, we set out with the FAA to create a system called the Low Altitude Authorization and Notification Capability, which took airspace authorizations from a 90-day paper process to a 2-second digital process through our platform. And thousands of people are using that all the time to fly in controlled airspace. So those are the kinds of things that we do every single day now. I would say there was one other part of that question, which is how does this translate to automating all of air traffic control? Something that I didn't anticipate when I started this company was that air traffic control agencies were going to see what we do with drones as disruptive for everything that they do in managing air traffic. And over the last 4 years, we've been getting approached by all of these FAAs of the world saying, hey, we want you to come here to help us with drone traffic, but not only because we need to solve for drone traffic, because we want to learn from you and we want to disrupt the way that we manage all air traffic so it can be even more safe and even more efficient. So I do see it going in that direction.
Okay, do you want to pick your favorite question from those ones?
Okay, so connectivity is an interesting one. The question is, how will connectivity be maintained to implement these flight path commands? So it really depends on where the flight is happening, at what altitudes, the use case of the flight, and I think that we need to really lean on the lessons from the internet here, right? Sometimes your best connection is a wired connection, sometimes it's Ethernet connection, sometimes it's your cell phone. you have lots and lots of ways to access applications on the internet. And these airborne vehicles need to have lots and lots of ways to access the airspace services as well, because the best connection really depends on where you are. Now, a lot of these flights are going to be happening in cities. And in cities, we have really, really great connectivity. The commercial data networks that are available for all of us that we use on our phones are hugely scalable, very, very secure, and pretty reliable. The pretty reliable is going to become really reliable pretty soon with 5G. But that is the most scalable connectivity system that's wireless and available now. I don't think we need to reinvent the wheel, and we've been doing a lot of demonstrations and experiments and actual operation over the last several years using LTE to manage drone activity, and it works very, very well. Of course, there are going to be some remote areas where LTE doesn't work, so you need satellite connectivity in those areas, or other types of command and control links, ISM band radios, or whatever. There's a ton of ways to connect. But the important thing is that the airspace services be a platform that's accessible regardless of how you can make a connection to the service. And so it's an open system. So long as you can make a connection to the internet, you can benefit from these services.
And do you want to do that? Ask the last one, Ben. When will the integration, holistic approach happen?
Well, it's happening now. I mean, this is not an on-off switch. It's an iterative set of services. And so already today, we are bringing in manned aircraft traffic information into the UTM system. The UTM system is pushing drone traffic information into the traditional air traffic management system. But there's a lot more to do, right? We'd love to get drone traffic information into the cockpits of helicopters so that helicopter pilots can know where drones are operating, for example. That's something we will do. It's going to take some time, right? But there's a whole lot of steps in this full integration path. I think it's important that we don't think of it as it's happened, it hasn't happened, but it's happening all the time.